This video is going to review how to evaluate and graph piecewise functions. First, just want to kind of talk about what a piecewise function is. Basically, you'll have a function, some kind of function notation or function name over here. It could also be a y instead of f of x. And the function, there's several functions. For it to be a piecewise function, there's at least two. And the function rule is written first, and so the 3x minus 5 is the rule, and the x squared minus 2 plus 2 is the rule, and the second part of this tells you when it applies. So it goes 3x minus 5 comma, this rule applies when x is greater than 4. The other rule, x squared plus 1, applies anytime x is less than or equal to 4. And what you should see is all the domain values of x covered. So basically, between x being greater than 4 and x being less than or equal to 4, I've pretty much got all my bases covered. It's going to cover all the numbers. And to evaluate the function rule, or a piecewise function, you look at the input value, or the x value provided with. Okay, in this case it's a 3. And I go back up here and I look at the second part of each function rule to determine which one I'm going to use. And it says, well, since 3 is less than 4, I'm going to use the second one, where x is less than or equal to 4. That means that I use the rule x squared plus 1 when x is 3. And all I do is replace, of course, the x with a 3 and simplify. And in this case, it'd be 3 squared plus 1, that's 9 plus 1, or 10. And so f of 3 for this piecewise function is equal to 10. Okay, for this second one, if my input value is 0, I'm going to go back up here and think, okay, well, that's going to apply to this one here because x is less than 4. Same thing. We'll do x squared plus 1, substitute a 0, and we get 1. Is our f of 0 equals 1. All right, let's take a look at 4. This one's a little trickier. This one says if x is less than or equal to 4, I have to use this function rule. So I'm going to use the same function rule. It's going to be x squared plus 1, only instead of the x, I'm going to replace it with a 4. So 4 squared plus 1, which 4 squared is a 16, and plus 1, that is going to be 17. Let me kind of divide these up a little bit. Okay, so f of 4 is equal to 17. And then last, we have f of negative 1. Well, this is yet another one where x is less than 4. Let me go and change this up and make it, just so we can try a different number. Let's just make this, instead of negative 1, how about 44? Yeah, I'll make it 44. Okay, so f of 44. Well, 44 is a number that's larger than 4. So I would be using this rule up here, 3x minus 5. Let's try that. 3x minus 5, only now it's going to be 3 times 44 minus 5. So we have to think about what is 3 times 44. Well, let's see, it's 120 plus 12, that's 132. 132 minus 5 is 127. Okay, so basically you're just really determining which rule is going to apply. I'm making a big mess there. That's supposed to be a 44. Let me fix that. There we go. F of 44 equals 127 because I used the first rule for this one. But for all the other ones, f of 3, f of 0, and f of 4, because those three numbers are less than or equal to 4, for those I used the second function rule. Okay, so I think you're getting kind of an idea here. Let's take a look at some graphing. You're going to see the same type of function notation. Here I've got a piecewise function that's got two rules. One represents the values when x is bigger than 1 or greater than 1, and the other function rule applies when x is less than or equal to 1. So what I like to do is start out by making a on my graph a dividing line in the graph, so I know kind of where each function is going to where the split is going to happen. And I'm gonna go ahead and just be safe and use increments of 1. So that's 1. Let's skip here. 1, 2, 3, 4, 5. Here's a 5. We'll go 10 here. 1, 2, 3, 4, 5. Just go with -5. Let me just do my 5s, and then we'll all agree that every unit is 1. 1, 2, 3, 4, 5. So -5 here. Okay. My dividing line for this function is 1. All right. So I'm just going to, just kind of to help me out, I'm going to go right down the 1 where x is equal to 1 and write a little dash, make a dashed line. And then when I'm all done graphing both of my functions, that's going to tell me where I separate the two functions. And I'm simply going to take the first one, 2x minus 1. I know that applies when x is more than 1 or greater than 1. So I'm going to graph this like I would y equals 2x minus 1. In slope-intercept form, y equals 2x minus 1, my slope is 2, and my y-intercept is -1. So if I was going to graph this function on the y-intercept, or I'm sorry, on the y-axis, I would start at -1 and draw my first point. And then since the slope is 2 or 2 over 1, I'm going to go up 2, right 1. Up 2, right 1, a few times. And I can go ahead and graph this whole entire function all the way across the whole entire graph. But since I know that it begins, this graph, I'll use blue for this one. It begins with the positive 1. I'm going to just use that piece of it and draw the line from there. And then we'll talk for a second. I could use a straight line, but I'll just go ahead and freehand it. Okay, now it says that this function rule applies when x is greater than 1, but you notice it says greater than 1. It doesn't have an or equal to. So I need to draw, I'm going to erase just a teeny bit of this, make it a little bit smaller there. I'm going to draw a little open circle right at that point, so that you can see that the value 1, or the value x equals 1, is excluded from this portion of the graph, okay, right here. Now let me go ahead and graph, and I will use, I guess I could just use red for this one. I'm going to use red for y is equal to -x plus 5. That's the second function rule, where my slope is -1 and my y-intercept is 5. Okay, so if I was going to graph all the way across this little graph, I would start with the 5, positive 5, put my little first dot there. My slope is -1, which means down 1, right 1, down 1, right 1, down 1, right 1, and so on. Except I know that it only takes place at, left of x equals 1. So left of this dashed green line, because it only applies when x is smaller than or equal to 1. So I think I'll just start my graph with a solid circle at 1, 4. Okay, 1, 4. This point right here, 1, 4. And that's the point where if x is 1, it would be -1 plus 5. Well, that would be a 4. And I'm going to go ahead and since my slope is -1, I should be going downhill from left to right, but going from right to left, I'm going to go up 1, left 1, up 1, left 1 a few times. And then I can just freehand my graph heading that way. Now, when you look at your graph from left to right, what you don't want to see is any place where there's an overlapping x value, or sorry, an overlapping, basically two y values for the same x value is what I want to say. And notice right here where it says x is 1, this is an open circle and this is a filled in circle. So just by looking at the function graphically, I could look at it at any point and find the y value no matter where it was on the x-axis, including at 1. And I would see, well, it's not this one, it has to be this one. Okay, let's try a couple more. Okay, this function rule, or this piecewise function has two function rules. One applies when x is less than or equal to 2, and one applies when x is more than 2. So I'm going to go ahead and draw my dashed line to help me separate my two parts of this graph. right down, x equals 2. I'm not going to label all the numbers. We'll just agree that each square is 1 unit. So this first graph would be of the y is equal to negative 3x plus 2, or h of x is equal to negative 3x plus 2. My slope is negative 3. My y-intercept is positive 2. So let me just graph that one first. I'm going to start with my y-intercept first, and I would put a point right there. And then my slope's negative 3. So down 3, right 1, down 3, right 1, down 3, right 1. Okay. I could also go up 3, left 1. And again, this one applies when x is less than 2 or equal to 2. So I'm going to go ahead and I'm going to use my straight line. I'm going to go ahead and start at this point here, which is 2 comma negative 4. Okay. Now I'm just going to draw my line using my little line tool. Oops. Dang it, I made a mess there. Try it again. There we go. Right there. Okay. And give it some little arrowheads. Now at the value right here of 2 comma negative 4, and that's what my graph is showing. I can also verify it by plugging the value of 2 in. If it was 2, it would be negative 3 times 2 plus 2, or negative 6 plus 2, which would give me negative 4, right? So this is a correct point, 2 comma negative 4. But I want to make sure and put a nice, kind of emphasize that it's a solid circle there because of this, the or equal to portion of the inequality symbol. All right. So in the other function rule, 1/2 x minus 4 applies when x is more than 2. So if I was going to graph that, I would graph it with a slope of 1/2 and a y-intercept of negative 4. Okay, so my y-intercept is negative 4. I'm going to start down here. 1, 2, 3, 4, right there. And from my y-intercept, I'm supposed to go up 1, right 2, up 1, right 2, up 1, right 2. It only applies when x is more than 2. So let's do a couple more. All right. So I can see that one of the value at 2 is 2 comma negative 3. And I can also verify this one by just substituting the 2 into the expression. So it'd be 1/2, instead of 1/2 x, it'd be 1/2 times 2 minus 4. Well, 1/2 times 2 is 1. 1 minus 4, it does equal 3. Or, sorry, negative 3. So this would be a valid point, except that this function rule only applies when x is more than 2. It does not apply to 2. So I need to put an open circle on that one. So I will do like a little open circle there. And then from that point, and at this point, I'm going to just go ahead and erase my coordinate point, so I don't really need that. You can see the line better. Look, I'll just freehand this one. And it's, again, the slope was 1/2, so it's going to be 1 over 2, right through here. There you go. Okay, again, looking from left to right, you see basically two totally different graphs, but one applies everywhere from positive 2 to the left, and the other one applies from positive 2 to the right. And then at positive 2, the green graph applies. So that's the top one because of the or equal to sign there. So as I look from left to right on my x-axis, I can see that across this domain, there's only one, there's only one one value for each x, okay, which is one of the basic tests of a function.